Alright, so if we have an ionic compound, what are options of what it's made of?
Non-metal to metal.
So non-metal to non-metal, or non-metal to metal. Or has what? A polyatomic ion, right?
You need to replace the ion.
Right.
Pardon the interruption, it's in his office.
Yes,
Do you have Dylan Doomstorm?
sure do.
Can you send him to the tennis office to check out, please?
Hey.
Thank you.
Polyatomic ion.
Mm-hmm. Alright. So, or it has a polyatomic ion. Okay. The cation. Is the cation positive or negative?
Positive.
It's positive. Must come first. Alright. Alright.
Oh, okay, so when you're writing compounds, the cation must come first.
Yes. Alright. The total charge must be 0. How do you get that?
It's like a whole little.
Don't you like
Multiply with the amount of the.
you plug in the charges, don't you?
Okay, you get that by adding
What are you trying to say?
oxidation numbers. If 0, drop them. Smooth elements.
Miss Patty, what do you mean by zero drop them?
If, like, plus 2 minus 2. If they add up to 0, get rid of them. Don't write them in the compound.
Okay.
So, let me give you an example. Everybody catch up with me and then I'm going to add a slot. Because I'm out of room. So I'm going to write one more thing. If not, get rid of plus and minus. Swap them. And they What's a subscript?
It's
The amount of
the number of the.
It's the number at the
bottom
bottom
is the
that
amount
tells
of
you
that certain amount.
the amount of each element. Okay? The subscript is the number at the bottom that tells you how many of each element. So I'm gonna stay in here for a second and let you catch up. Alright. Then we're gonna do a few.
Get rid of what?
Get rid of the plus and the minus.
Wait. Smush elements?
Yep. I'll show you.
So that say become subscript?
Become subscripts. Sure does. In my really sloppy handwriting. Alright. okay here?
Yeah.
Yeah? Alright. Let's try a few.
You gonna? I quit my job.
Alright, so I got three different options here. Alright, Mg2 plus Cl1 minus. Does that add up to 0?
No.
No, it doesn't.
Wait, how can you say?
Plus 2 minus 1
That's one, bro.
adds up to 1, right? Doesn't add up to 0. So, I get rid of the plus, I get rid of the minus,
You swap.
the 1 would go down here, the 2 goes over here. I don't write a 1. It's understood if I write the symbol, I use it once. So I write an Mg, I write my Cl, I put a 2. Okay?
Okay.
How would I name that?
Magnesium chloride.
Magnesium chloride. Because a binary ionic has 2 elements. I name the first. I name the second, and I change the ending off the periodic table, the INE, to IDE.
How do you know to change it to?
Okay. Chlorine is on your periodic table. If it's on the periodic table and it's an anion, meaning it's negative, I take off the INE and put IDE. Or I take off the UR or the OUS for sulfur or phosphorus and I put on IDE. So if it is on my periodic table, I take off the ending and put on IDE.
And what if it's hot?
Okay. We'll get there. That's why I picked all three of these. There's a method to my crazy madness every time. All right. What about the next one? I'm not going to put a fourth one up here.
It's the same thing.
Well, they add up to 0.
Yeah, they add up to 0.
Thank you.
Oh. I already have something to
They add up to 0, right?
Right.
Yeah.
So I get rid of everything at the top. I get rid of the 3. I get rid of the plus. I get rid of the 3. I get rid of the minus. It's just FEP.
Would you get it wrong if you left those
What did I get wrong
in?
here with the numbers?
So crossed it.
Yes, you would. Okay. All right. That 3, though, is important because it tells you the charge of the iron. What is iron?
Metal.
What type
A
of metal?
transition metal.
It's a transition metal. Okay? Now, this is iron 3 phosphide
Because of the 3.
because of the 3. And P is phosphorus, right? And it's on the periodic table, so it ends in I. So I have to name the charge. Iron 3 as a Roman numeral, phosphide. All right?
So anytime it's a transitional journal, you always put
Anytime it's a Roman numeral, or a transitional, you have to have the Roman numeral. Okay. What about here? I have copper, and I have this. What is this?
That's a.
It's not a compound, it's an ion. It's a polyatomic ion.
phosphite.
Not phosphite. Phosphate. PO4 is phosphate. Okay? So that's not on my periodic table. It's on my ion sheet. So I don't change its name. I write down whatever the sheet of paper tells me. Okay? I still do my swapping. Does plus 2 and minus 3 add up to 0? No, not at all. Okay, so I get rid of my plus. I get rid of my minus. My 3 is going to come over here. My 2 is going to come over here. I need 2 PO4s, which means I have to enclose the PO4 in what?
Parentheses.
Parentheses. Okay? So CU3 PO4 2. The name of this is what?
Copper.
Phosphate.
Copper what? Copper? No. Copper 2, because it comes from the charge of the copper.
Oh.
Copper 2. What you got? Okay.
I was just gonna ask, can we like multiply the 2 by the 4 and the 1?
Nope. You do when you calculate the mass, is when you multiply. But when you write the formula, you do not multiply. You do not say Cu3 P2O8. That's wrong. Okay? Good question. All right. What about this one?
Is that 3 plus?
It is a 3 plus.
When you swap the charges.
Okay, we got to swap the charges. We get rid of the 3, the plus and the minus. 2 comes over here. 3 goes over there. What do we do?
And then
Was that 3 plus?
well, it's a transitional metal.
Still a transition metal.
So you're going to put the Roman numeral next to it. It's 2 upward.
Fe2O3.
Yeah, Fe2.
What's its name?
Is iron 2 aluminum.
Not iron 2.
No, it's iron.
Iron
Oxide.
3.
Iron 3. It's got to go to the charge.
Iron 3.
Iron 3 oxide. Okay, let's do a few more. Guys, I don't mind doing it, but you got to practice it. Okay, let's do it this way. Let's do it from the formula. Because this time I've given you the charts. Let's go backwards.
Alright, let's do it backwards.
Okay. Malik, wake up. You need to be writing this down. All right, let's go this way. Oh my God.
Oh, man.
So we're just doing the formula, right? We're not naming
Okay.
it.
Now I've given you the formula.
Right.
I want you to name it.
Oh,
Okay. So that may mean you have to break it down first to be able to name it.
The first one is Colgate.
Cobalt.
Cobalt, yeah. With Roman numeral 3.
All right.
Chloride.
So how are you going to name these? What do you have to do? You have to break it down. You have to go back to the ions, right?
Yeah, C.
All right. So do it backwards.
The 3 goes back up.
Okay. All right. Part of it's knowing what's a transition metal and not. Part of it's knowing what's a polyatomic and not. All right? Okay. So, this is why I said you got to have everything out. You got to be writing this down. So to do these, undo the crisscross. Okay? So we have CO 3 plus, Cl 1 minus. All right? So we have cobalt 3 and then Cl.
Miss Petty, how do you know that cobalt has
Because I can undo the crisscross. I bring the 3 up here and then the imaginary 1 over there.
How do you know if it's negative?
Okay. Okay. You gotta listen. Whatever goes this way becomes positive. Whatever goes that way is negative. All right. Look at AL. Where is AL on the periodic table?
In the P section.
Is it a transition metal?
No.
No. So do I need to worry about its charge? No. So I can just name it.
Wait, what? I thought you had to put like. I thought because I have more than one.
Nope.
You don't do that?
Nope.
No?
Nope. I only need to undo it if it's a transition metal to know its charge.
I know, but don't because when you undo it, you get like tri-aluminum.
No.
No.
I only do prefixes if it's covalent.
Oh.
Okay? So I only have to undo it if it's a transition metal to know its charge. And I only have to undo it if I don't, like, I need to recognize that that's a polyatomic. Because it's sulfate. Okay? That is sulfate. All right. So this is Al, right? Yeah. That's aluminum.
Yeah, oh, wait.
It would be a 3 plus charge, exactly. O would be a 2 minus. And that's a standard oxidation state. And then O is what? It's oxygen, which becomes oxide.
You don't put aluminum 3?
Nope. Because aluminum is not a transition metal. Alright. Name this one. Rb2SO4. What is Rb? Rubidium. Where is rubidium?
It's on the first row.
Way over to the left in the first row in the alkaline metals. So do I need to name its charge?
No.
Nope. I just need to name rubidium and sulfate.
What are you laughing? So why don't you, for aluminum, why don't you put that thingy?
What, the Roman numeral?
Yeah.
Because it's not a transition metal. It's not in the D block. It's not in that flat cutout part in the middle. It's in the tall part right here in number 13. I only put the Roman numeral if it's between here and here. Since aluminum's right here, I don't do it.
Oh, I have no idea.
Okay?
Miss Penny, when you redo that, would be RB4 positive and SO.
Nope.
Wait, so this whole
Because RB is a +1 because it's in the first column. The 2 comes up here. The 4 is connected to the sulfate.
Oh, okay, yeah.
The 4 is glued to the O. Alright. ZnF2. What do we do?
Oh, okay, so first
It's zinc 2. I have to undo it because zinc is a transition metal.
David chlorine.
How much is
Because
it?
that's just chlorine.
Yeah.
Imagine. 75%. Isn't that like
It looks like some New Zealand
All right. Okay. Question. Does that make ionic make more sense?
Yes.
Yeah?
Yeah.
Yes.
Okay.
All the
God.
bionic.
All right.
Definitely study bro. I want to get checked out.
Okay. So, next step was covalent. What is it if it's a covalent compound?
They're sharing electrons.
Okay? They're sharing electrons and it's two nonmetals.
No. Because I don't want to get too pointless.
Alright. What else do we know?
They
You
don't
have to use
They came out.
use prefixes. Always on the second.
Oh, yeah.
Metal to non-metal.
Rachel.
The second element gets the suffix "ide." Okay?
Wait. The prefixes and suffixes on the second one always?
Yes.
Alright.
Alright. First element. Doesn't get the prefix mono. Alright. And there's your prefixes again if you need them.
And then we have those.
Alright. You can put those on your periodic table or on your ion sheet if you need to, if you think you won't remember them.
How the compound different.
Okay, stay.
Next, we can use our ion chart on the test as well.
Yeah. Dude, I don't have all this memorized, and I've been doing this for 20 years. Well, you figure I started learning chemistry when I was your age. Okay, I'm dating myself. I'm telling how old I am.
Exactly.
So let me think. You were what, 15, 10 years ago?
Oh, bro, who said that, bro? Yo, wow.
Okay. So, we okay here?
Yeah.
Yeah? Alright. So, of the three types of compounds we've learned so far, covalent's the easiest.
Oh yeah.
Thank you.
We good?
No.
Yeah, can I
Wait, I have a
pour?
question.
What?
Can you use the polyatomic ion?
In covalent? No.
No?
No. Okay. Now, here's the trick. Polyatomic ions are made covalently. They're made out of covalent elements. But they have enough electrons to have a charge, so they are ions. They're covalent elements. They're two non-metal elements. So they are covalently bonded together, but they have electrons to be ionically charged. So polyatomic ions look covalent, but they act ionic. So they have a covalent property to them, but they act ionic in how they bond. So they act like both. Alright. But no. Can you give me a polyatomic ion and say I'm using that as a covalent compound? No, you cannot. Alright? It's an ion. Alright. So, if I said
Nitrogen. It's nitrogen.
hang on, that looks really bad. Nitrogen trihydride.
Oh.
I'm not gonna let you go to camera. You put stuff.
That's H2O.
Yep. So it's an N and an H and a 3.
Oh, dude, my head is.
Alright. So, what about this one? Hydride. Like hydrogen.
Is
Hydride.
that NH3?
NH3.
Oh,
Because it says
Mhm.
try.
Okay, I don't need to use it.
Alright.
No. It should be able to
What would silicon hexafluoride
It'll
be?
be SBL.
S for sulfur.
It's S-I. S-I-C-L-7.
6.
Right.
SiCl6.
You said 6. I wrote 7 down.
So the number always comes last.
Yep. P2O5. What would that be?
Wait. Phosphorus.
That'd be that phosphorus.
Pentaoxide.
Okay, depending on the book that you read, you're both right. It can have, you might see it written as pentoxide, where they drop that A because you've got the two vowels next to each other. Or you can see it written as pentaoxide. It just depends on the book. They're both right. Okay?
How do you do it?
I do pent. Whereas if I have a consonant right there, I'd put the A. Alright. So, covalent's fairly easy. Right? Okay. Covalence is it's prefixes and counting. To me, covalent's fairly easy. It's just knowing which prefix goes where. The prefix follows proceeds. Alright.
You good? No. What happened?
Alright. Let's do a little bit, we'll do a little comparison probably on Friday. Alright. We might do it live. Alright.
I was gonna speak some Italian, but now I forgot the word.
Alright. Acids.
Yes.
Huh?
Is there recording and sliding?
Yes. I'm at 31 minutes and counting. Why aren't you writing?
Bam.
Put your headphones up. They must start with H. Alright?
All of them?
Yes.
Does it start with like hydroxide?
Oh,
Okay.
That's for the
But for the naming, you don't.
Okay.
binary?
If it's an acid, it starts with H.
But with the
All of
naming,
them
it
start
doesn't.
with H, like chloris.
The formula.
Oh, okay.
But the name
Okay. Let's start with H as the formula. Alright?
Okay. You ain't trademarked it though. Try it.
Alright.
Put it on.
So, you have binary acids and you have tertiary acids. Tertiary acids are also called oxyacids, which means they contain oxygen. Okay? We okay here? Alright.
We have acid.
tertiary.
Huh?
We have acid in our body.
Yes.
Tertiary.
You have binary, you have stomach acid, which is hydrochloric.
Oxyacid?
You have, there's typically a little bit of, I don't know. Alright, we okay here?
Yeah.
Alright, because I'm gonna need a screen.
No, that's bad.
Oh, good.
Oh wait, I thought you meant. Actually, no. If they, I mean, come on, when they first come out. When you come out, you barely saw it.
They have to hold you like this, like in your As they come up and start digging hands, they're like premature. They're gonna die.
Wait.
A baby. He said, don't they come up like this big? Because they're fucking premature, they're gonna die.
No.
Exactly.
I thought it was
She's not talking.
your mom and I
Yeah,
just
no,
weird.
11. Do something.
I didn't say that. I didn't say that. I did say that, but I did not say that.
All right. So with the binary acid, the anion, the negative part after the hydrogen, it ends in I. So chloride, bromide, iodide, fluoride, cyanide, sulfide. Okay? You have to put aqueous, AQ, at the end of a binary acid to designate it as an acid. Otherwise, since it's binary, it can be looked at as a covalent compound.
This is CO.
Yep, ACl. And AQ means aqueous, dissolved in water.
Does the AI not come first?
You could name that compound as a covalent compound. You could name it as hydrogen monochloride. So if you don't put AQ, you're naming it as a covalent compound, or you have the option to. Someone reading your work wouldn't know to name it as an acid. Okay? So the naming system
Oh, okay. It has to be at the end of the formula.
at the end of the formula.
So Miss Penny, I remember you said that Kool-Aid was aqueous.
Yeah.
How do you, what's the chemicals in Kool-Aid to make it an aqueous?
Okay, all aqueous means is something dissolved in water. So the fact that you've dissolved Kool-Aid powder, which is sugar and dye and flavoring and other stuff in water, you have made that packet of stuff aqueous. That's all aqueous means.
What flavor? Because you're not allowed.
I really am. I grew up in Black Thank you.
So the naming is hydro, then the root of whatever anion you pick, ic, acid. So, for example, HBr is hydrobromic acid.
Can some
You know,
No, a tertiary acid does not get hydro. Only those 6 binary anions get hydro. If it's not one of those, don't put hydro.
You said that all acids have hydrogen.
They all get hydrogen at the front in the formula. But in the name, they don't get hydro.
How can you tell the difference between a tertiary and a binary?
The presence of oxygen in the formula.
Oh, okay.
Good.
The difference between binary and tertiary, when you look at the formula, is the presence of oxygen. If you're given the name, the presence of the word hydro tells you whether it's binary or not. We're going to try.
Wait.
We're going to write down the rules for both, and then we're going to try them. Okay?
So, this might be a dumb question, but would
No dumb questions, just my sarcastic response.
would water be binary?
Okay. Water is considered an amphoteric substance, meaning it can be an acid or a base. So you don't name it as an acid or a base.
It's just there.
It's just there. Because it's technically dihydrogen monoxide or dihydrogen monoxide. You don't name it as an acid or a base. All right.
H2O.
All right. Tertiary acids.
Well, like, it's your birthday, it's like, it comes
It's
in
gonna
a
be
little.
present. Like, if you want me
Yeah,
to
it's like, it puts a birthday cake next to you.
Yeah.
Like, you know how you
Yeah,
get
that's
out
what
like
it
the
is.
cake?
It just-
It's really like that. And then you can send people like
It's They updated.
All right. Tertiary acids come from the combination of hydrogen with oxygen containing polyatomic ions. So you have to look at the name of the polyatomic ion to know how it's going to be named. If it's an ite ion, it becomes an us acid. If it's an ate ion, it becomes an ic acid. Do not use hydro in name.
Miss Eddie.
What, honey?
You put. What about Ivy?
None of these acids use an IDE ion.
Isn't that for
Okay,
the
I'm just saying, it's one of the polyatomic ions.
None of the polyatomic ions will have IDE
That's how they
if they're
do.
tertiary.
Right.
What's her name?
What? Seth?
For I is to OUS.
Ite is to OUS. Ate is to it. You take off the ite.
Don't use hydrogen. Don't use hydrogen.
Take off the ate. And you put on it. Alright, we're going to do a few.
Yeah.
Do not use hydro. Oh, wait, what? What is that? Hydro, what does that say?
Do not use hydro in the name.
Oh.
What did you cross out under,
So like you would take off the ite and you put on OUS. You take off the ate, you put on it.
okay.
Alright. So we're going to do a few.
Do not use hydro.
This is going to be the longest video to upload ever.
You have to render it. Okay. No, you don't.
Alright. Here we go.
Miss Betty.
Yes?
My cup is water.
Go ahead. Use the water bottle. That one's broken. Louise!
Is that this person
He's gonna do that like the whole head movement. Oh.
No, just do it. Go to school.
Shush.
Oh.
Don't.
Easy.
Oh, my God. What is it? Because remember, you take the root of the anion.
Okay.
Miss Petty, carbon and nitrogen are both
Okay.
anions.
All right. Stop. Here we go. All right. Look at the first one, HCN. It has an AQ beside it, right?
Yes.
So it has to be on my list of my things that are binary. So what is CN?
Carbon and nitrogen.
Okay.
Carbon and nitrogen.
It means it ends in I, right?
Yes.
Happens to be the one polyatomic that ends in I. So look at your polyatomic sheet. It's the one polyatomic that ends in I that counts. It's cyanide. So it's cyanide, so it becomes hydrocyanic acid. It counts as a binary because it ends in I.
On the chart.
Right. Okay?
How do you look up HCN on chart?
You don't. You look up CN. Okay? CN is cyanide. The root is cyan.
Right.
So it's hydro. Cyanic
Because it has the H.
acid. All right. We got to do these a little bit backwards. Sulfuric acid. It ends in ic, right?
Right.
So I'm going to take off the it. That means I need sulfate, which means I need SO4 2 minus, right? Means I need to hook it to an H plus. H plus and 2 minus doesn't add up to 0, which means I treat it like an ionic compound, which means the 2 comes over here, right?
Yeah.
So it's H2
SO4.
SO4. Phosphorus acid.
This becomes
It ends in
phosphate.
OUS. I take off the OUS and technically the OR. It ends in ite. It becomes PO3 negative 3. I gotta add an H to make it an acid. Well, that doesn't add up to 0.
H3.
So I gotta move that 3 over there, just like I did in ionic. So I gotta have H3 PO3 HNO2. Okay. Is it binary or tertiary?
Tertiary.
Tertiary, you got oxygen. Okay, I don't care about the H. So I gotta look up NO2 on my ion chart.
It's nitrite.
It's nitrite. So I take off the ite and I add OUS.
Wait, how do you know it's not
Because look at it.
If there's NO3 and there's NO2. I look up the name for NO2.
Look, what's your name? I don't know the name.
Okay. It's not binary.
Because that's oxygen, yeah.
All right. Okay. Now I'm asking you for nitric acid. I did this intentionally.
It's nitrate.
Okay. Take off the ic. I put on 8, which means I need the formula for nitrate. What's the formula for nitrate? It's nitrate.
NO3.
Nitrate.
NO3.
NO3. That was a yell.
Oh my
H plus, NO3 minus. Does that add up to 0?
No. Yes.
Plus 1 minus 1. Yes, it does. Alright, H2O3. Okay. HI, AQ. It's binary. Because that's got AQ beside it. So what's his name? Hydroiodic or iodic, however you say it. Uh-huh. Alright. Next one.
Okay, so that's hide no.
Yes?
Hydro.
I'm down.
Quit taking notes.
Sulfuric.
One plus one is not.
S by itself is sulfuric. There's no sulfate. Sulfate is that right there. Okay.
Wait, I have a question. Can
Yeah.
can you simplify it like that? Like how we did the, I think it was the E and
Can I write an empirical formula for that?
Yeah.
No. I can't simplify 2 and 1.
I mean, I'm talking about for the,
What was that?
two, oh yeah. What about for
Okay.
phosphorus?
HIO3.
That's tertiary.
Tertiary.
It's
Are you gonna use ick?
It's iodate.
Yes.
So it becomes ick.
And then it's gonna be
iodic.
iodic.
So it's iodic acid.
Oh, that's cute.
HC2O4.
That's awesome.
It's oxalate. So it becomes oxal.
Ick.
Ick.
Oxalic. Oxalic.
All right.